Hello guys, so today I'm going to explain you about a very well-known data structure known as set, which happens to be very useful when it comes to competitive programming. And yeah, just to set the expectation from the very beginning, I'm not going to deep dive into the internal structure of set and how is the data stored in this set, like talking about the self-balancing tree, either the red black tree or the binary search tree. So I'm not gonna get into those details. I'm just going to explain you how does set work, and I will try to explain few functions, few methods which sets provides us, and then using those methods or functions I'll try to solve one problem from one of the platforms, and I'll try to explain all its application. So let's get started. So to start with a very brief introduction about set, what are sets? Sets are basically a container where we try to store certain type of elements into it, and those elements should be uniquely stored in a container. In the container, that means if a particular element is already there, it shouldn't be inserted. So yeah, and I have written integer type of set here, but it can be essentially anything, like it can be character, it can be a floating value or double value as well. So I'm going to explain most of the things having integer as a data type here. So let me explain you how do we insert some data into our set. So the method is very simple. We just insert certain number, or because here it's integer, so I would try to insert certain number which is an integer only. And let me insert one more similar element, and then I'll show you what's the size of this set. So now you are already aware of two functions. One is dot insert and the other is size. So insert would take an element and insert it into our set, that is the container, and size would tell you the size. So as you can see here, it's only telling you that the size is only 1, although we try to insert two elements. So what it does is it basically checks whether this element is already there or not. If it is there, it doesn't insert. So that's how it that's why it actually stores only the unique values. And if we change it to 30, you can see the size changed to 2. So yeah, so now let's just try to insert few more elements, and then I can show you how can we uh, iterate over our set and see what are all the values are stored. So I'm doing some random insertions here, like putting in some random values here, and we'll try to show you. So basically what happens when we insert some value, it stores them in a particular manner, that is by default it stores in ascending order. So let me just explain you how can we traverse those through our set. So we can define an iterator of set, and it should be pointing to the beginning of the set. So set.begin is an iterator which is pointing to the beginning of the set, and then if we start traversing this set, so what we can do, we can traverse till the end, that means until this iterator is not the end of the set, and we keep on increasing the iterator every time. And if we try to print the value of this value stored in our IT, then what we can do, because this is an iterator, that is a pointer, what we can do is try to dereference it, and let's just see. So now as you can see, there are certain number of values. All the values which we inserted were unique. So actually the size itself is 5, and 5 is the total number of the values that we inserted, and you can notice that all of them were printed in sorted order, that is in increasing order. So that's what set does, it keeps let me just add one more value here, so you still will see the same number of values. Alright, so we didn't actually insert 15 because 15 was already there, and what it did is also on top of that sorted these elements. So this is one way of iterating through our set. What some higher version of C++ also provides us, the auto variable, where you can just define this auto set and you can just iterate over it like this. So this will also do the same. All right, so because here x is already dereferenced here for IT, so you can simply see all those values. So now you have learned how to insert, how can you check the size, what are the set dot begin, what is set dot end, how can you find an how can you define an iterator, and how can you iterate over the set without defining an iterator. Let's go to the next functions. So another very common function which we generally use more often is dot find in set, where we try to find whether a particular element is there, existing in our set or not. So basically what we do is we can just simply check. So for example, whatever the value we have inserted here, let's just try to see if there exists a value of 45 or not. So this is how we check. So dot underscore set dot find, you can name it anything, I hope that's not confusing you. So let's just try to search for 40. All right, so if this exists into our set, then it should not be in the end, like shouldn't be pointing to the end of our set. So that's how you check that. If it is not in the end of this set, that means we have found, else it should say the element doesn't exist. All right, so here you can see that 40 does not actually exist, so it did tell you that hey, it didn't exist. And what if we try to see that for 30 it shows that 30 exists. So in case if you are wondering how do we find, so you can just, instead of defining an iterator, you can simply just check here as well, set dot find 30. If this is not equals to the last pointer of the end, of the set, that means it existed somewhere and my iterator is then pointing to that value. All right, and this way we can also confirm. So what we were doing previously is this, that we defined an iterator and we try to see whether it existed or not, and if it didn't reach till the end, that means it did exist. Then let me just print the value of the, what was the value which was stored at that iterator, where did it match this particular value. So it has to be 30 only. Let me just show you. So what I've explained you here, this is what we are doing. If we do dereference, if we do dereference this pointer it, it should tell you the exact value. So here it is telling the value that is stored at this particular pointer. All right, so let me just also clear one more thing, that we shouldn't get confused when we defined auto here and we didn't dereference the x to get the value present at this value, because auto is something which automatically sets the type of this value. And in this way what we are doing is we are iterating over the value of each element in this set. All right, so this will automatically set the type of this x as the value which is inside this set. And here dot find is a function which returns as an iterator, so auto here will automatically set this particular value as an iterator. All right, so to get the value stored at this point, we do need to dereference here. But here what we were doing is, because I said, as I said, in the some higher versions of C++, that is above I guess 11 or 14, we can also iterate like this without having to define, as we define some custom iterator that we do for array, if you remember something like this. All right, so we don't have to do that. If this is an array or this is a vector, we can just simply traverse through it by defining this colon. And so x is actually a value here, and here it is an iterator, and both of them are defined as auto. So auto is basically setting the type of this variable automatically. The next thing that we should learn for is dot erase method. It's although not used very commonly, because most often you would find a situation where you would want to delete something out of the set, but just in case. So how do we do that? So there are some methods, like a couple of methods which I know, is that you can simply delete some value by calling set dot erase, and if you just tell it the values, like for example if you want to delete 15, all right, so let me just delete 15, and then let me just iterate over my set here. Then yeah, let me just iterate first here and then here. Let's see what are the difference that we have. So here you can see 3, 12, 15, 30, 34, but here 15 is not there, 15 is erased already, right? So this is one way you can erase. The other way you can erase is by actually telling like passing it the iterator. So instead of passing the value that you want to delete, you can also delete the iterator. So for example, if we found the iterator for 30, and if we want to delete 30 out of here, so we can simply do underscore dot set dot underscore set dot erase for that it, and then we just let me just redone, and then we can see that 30 is disappeared and now 15 is there, because yeah, we didn't erase 15. And then the other two very important methods which we find very useful for most of the problems that we generally encounter in computer programming is set dot upper bound and then set dot lower bound. So what are these set upper bound and lower bound methods? If you don't know already about them, I would recommend you reading about them. I'll try to share some very good resources in the description below. So let me just quickly explain what a lower bound is. Lower bound is basically pointer to the first element which is equals to or greater than the element that we are trying to search for, and then the upper bound is is a pointer to the element which is strictly greater than the element that we are searching for. So in our case we had let me just quickly print again and see what we had. I tried to let me blah, blah, blah. Okay, I get what the issue is. Okay, so yeah, we saw that in the end we had 3, 12, 15 and 34, and if we try to find basically set dot lower bound and set dot upper bound, let me just also let's define this lt as the lower bound iterator to the lower bound and ut as the iterator to the upper bound, and let's try to find 15. all right, so 15 for lower bound and 15 for upper bound, and then we would try to print both of these values. So how do we print? We do a dereferencing, and similarly I should do a dereferencing for ut. Okay, and let's print. So what do we get? We get that 15 is present. all right, so we get a pointer to 15 because we said that the lower bound will find the first value which is exactly equals to this one or just the next greater value. So greater value, that means it doesn't mean the 16, it finds the next greater value of 15 which is present in this set, and for upper bound it strictly finds the next greater value which is greater than this 15 in our set. So in our case it was 34, so it printed you this value. all right, what would happen if these values are not present? Like if we try to search for a lower bound for 39 and 30 and do an upper bound for 39, because both of them are not present here. So let's see what happens in that case. So let's quickly change them to 39, and this one also should be changed to 39. all right, and let's print. So what do we get? We get some random values which were not there in our set. So what happened here, when 39 we searched for, we got some and our iterators were pointing to some random position in our set, and which had some random values, and it printed those values. all right, so this is something we need to catch, and what I generally do is basically whenever I do a lower bound and upper bound, I always try to check whether this iterator, that means the lt, is not hasn't reached the end of my set. all right, that means if this value is within I mean this pointer is pointing to some element within our set, then only I would say what do we say is, yes, we have found all right, and otherwise we have seen the end. That means we have seen the end and we haven't find anything as 39. What is it? Okay, it complains that I haven't used this one. Let me just tell you. So yeah, it says that we have seen the end. That means 39 was not found. So in that case, what we can simply say is, because we were trying to find out here that how many elements are there or where should 39 lie in our case. So in this case it should lie in the very end of this set. That means all of these are smaller than this particular value that we are searching for, and that's what we generally do when we use lower bound and upper bound. What we do is basically we try to find out how many values are there which are bigger than this one, or how many values are there which are smaller than this one. So yeah, there are tricks to do the smaller as well, but yeah, I mean there's no trick required, all right, because you once you find that this particular value is pointing to certain element, then you can always get the number of variables and number of values on the right and left end of it. So yeah, sets that's how the upper bound and lower bound works. I hope I was able to explain you properly, and now let's try to see a real problem from HackerEarth, and I'll explain you how sets can be very useful there. So let me quickly read this problem statement. This problem name is help John HSBC. I don't know what HSBC stands for here, maybe some college name. So the problem statement says that you are required to collect n numbers from a bag. Initially the bag is empty. Whenever you put a number x in the bag, then the owner of the bag asks you the question, what is the greatest integer that is smaller than x and present inside the bag, and what is the smallest value that is greater than x and that is also present inside the bag. Alright, so if you answered both of them correctly, then only you are able to put this value into bag. So basically, instead of collecting, what this problem statement meant was that we need to insert some values into bag. Alright, your task is to answer the questions that are asked by the owner of the bag, and yeah, there are certain scenarios when this number does not exist. In that case, that means if there is no such values which is smaller than x or greater than x, in those cases we need to print -1, and the constraints are that the number can be as big as 1 billion, and then yeah, the size of the elements can be as big as 10 raised to the power 5. So for example, here the first line tells you the number of the number of elements that we are going to put into our bag, and for the first element there wouldn't be any smaller or bigger value, so we would obviously be printing -1 for the second value, as there is a value which is smaller than this one, so we would tell that hey, there exists a value 1, and because this was the second value and it is bigger than the previous value, so there is no other bigger value. For 2, there are lower and upper bounds for this one, as not bounds, I would say lower numbers, and lower than this value and higher than this value are present. For 3 as well. For 7 there is no value as well. So now you got the idea behind the question, and now let's try to see how can we solve this. So what we can do is we can just keep on taking each values, and like for example, once we have already put 1 and 4 in our vector or array, then what we can do for the next element, we can try to traverse the whole array till now, whatever the array we have collected till now, and try to see if there exists such values or not. If they exist, we do print, otherwise we print -1. So that will work, but that is not going to pass all the test cases here, because the n is 10 raised to the power 5, and what we are doing is we are doing an O n square operation here, so it is not going to pass for sure. So what else we have? So basically what we are doing here is we are trying to search for an element, whether this element's smaller value and bigger value existed or not. So for example, if we were searching for 2, what we wanted to know, whether just greater value than 2 and just smaller value than 2 exist in our bag already or not. So this is very much similar to what we discussed about the upper bound recently. So let me just try to declare one set here. So let's define set, and what we can do, we can just try to get x also can be defined here, and what we can do, we can just take this input and check whether this exists in our set or not. So as I said, what we can say is auto it equals to underscore set dot upper bound, and what we can do is we can try to search for x, and if x is already the end of that means, sorry, if the it is the end of our set, that means we haven't seen, and what we can do is we can just simply print. In fact, we want to print this space, so let me just set also some two variables, me and ma, where I would assign maximum value, I mean the greater value as -1. If it does not exist, that means we have seen the end of this set. Otherwise, what I would do is I want to know the values. So what I'm going to do, as I said, that we can dereference this iterator, that is it instead of ut. So this is what we will do for upper bound. So for example, if we search for 1, there isn't any value, so it will set ma, that is ma, as -1. Otherwise it will set ma as, so for example, if we search for 2, we would have seen 4 already, so it would be pointing to 4, just the next greater value of 2, and that's why it will be stored as the value, the dereferenced value here. All right, how about just smaller value? So I hope you don't get confused with the lower bound here, because lower bound isn't the value, isn't the pointer which is pointing to this just smaller value. It is actually pointing to this greater than or equals to the value which is greater than or equals to the value that we are trying to search for. For example, here also what will happen here, because all of them are unique, so x would always be pointing to the same value which upper bound is pointing to. All right, let me show you how. So let's for now assume that we already have 1 in our set. So what will happen when we encounter 4 and we try to do a upper bound within our set? So what we'll see, because there 4 is bigger than all the values, that is only there is only one value, so 4 is out of the bound of this set currently, so it should be printed as -1. But what will happen for upper bound, lower bound as well, is also similar thing. All right, because it is trying to find out the first value which is greater than or equals to, but in case of our problem, all of these x are always distinct values. All right, so we will never see a value 3, like we will never see, let's say for example we had 1, 4 and 5, and at any moment 5 will never occur later in the future, because we are saying that all these values are distinct. So if you try to observe closely here, the lower bound and upper bound both would always be pointing to same, so we could anyway choose either lower bound and upper bound to find just next greater value. But then how do we find the just lower value than the value that we just got? All right, so for example, let's say for example 2, what would have happened here when we receive 2 as the next element? So we are saying that we'll find the upper bound. All right, so the upper bound would be pointing to 4 here. So this 4, and the value, the it is a pointer which is pointing to 4. And what if we subtract this by 1, like decrement our pointer, something like this, and this will point to this value 1. All right, and we know that because this 2 is going to be inserted right before this one, all right, and there is no other element between 2 and 4 and 1, so the decremented pointer or the iterator would be pointing to the exactly smaller value than this one. All right, try to take some other example, and then you'll realize that. And yeah, there is one thing that I should definitely tell you, because we saw that in our case here we were trying to increment our iterator where was it, here, to go to the next pointer in our set. The same way we can also decrement and try to come to the other way around, like go in the different direction. And so while decreasing, we should take care of the case when we are not decreasing the pointer when it is initially pointing to the beginning. That means the underscore set dot begin here. Then in that, if it is pointing to set dot begin, then in that case our me should be as we did for the ma, it should be set as -1. Else what we are going to do, we are first going to decrement our iterator, and then we are going to set mi as the dereferenced value of it. All right, so and after all of this, we should insert into our, this value should be inserted to the bag, and bag is basically our set itself. And let's see, now try to print me and mi. Hope it works. All right, seems to be working. Let me submit. So it takes a bunch of time, and I hope I was able to explain you guys all the things. If there is anything which is unclear, or any doubt, or any feedback, or comments or suggestions for me, please let me know that in the comment section below. And there are other bunch of videos that I have done on multiple questions from different platforms, like from LeetCode, hackerearth, hackerrank, and few questions are there on Codeforces, and I would recommend you to watch those as well. Please let me know if there is other thing that you want me to make videos on. And yeah, it keeps on rotating, and there you go, seem to have working. Thanks. Yeah, it worked. So yeah, thank you all for watching my video, and I hope you enjoyed it. Please hit the like button and subscribe to my channel if you haven't already. Thanks.